Alright, Summer AP Physics. This is Lesson 7 on displacement. So we're going to deal with a couple of equations that deal with distance or displacement. Remember, if we're going in a straight line, distance, displacement, change in position are all the same thing. Okay, so how do we compute distance using acceleration? Displacement, distance, can be computed by multiplying the average velocity by the time and adding the initial position. So Alberto begins running 2 meters in front of the start line. He runs 8 meters per second for 10 seconds. What distance from the start line did he finish? So the distance is what you're trying to find. The velocity is 8 meters per second. The initial position is 2 meters. He started 2 meters in front of the start line, which we'll consider to be 0 meters. And then t is 10 seconds. So it's just plugging in the numbers. You get 8 meters times 10 seconds, 8 meters per second times 10 seconds, plus the 2 additional meters. That's 82 meters. That's the distance he ends up from the starting line. Now there's another formula. It's a little more involved. It involves acceleration. So you can use this formula that you see here. A car with an initial velocity of 10 meters per second, so that's VO, accelerates at 4 meters per second, that's acceleration for 5 seconds, that's time. What distance did it travel? So we're going to assume that its initial position is at 0. So distance is question mark, acceleration 4 meters per second, VO is 10 meters per second, and time is 5 seconds. So you simply plug it into the formula above. You don't need the x0. And if you just do the number crunching, you'll find out that it traveled 100 meters. Okay, so those are just 2 additional formulas dealing with how to get distance from velocities and accelerations and time.